This is the explanation of solution solubility in percent. So the question from 1 to 9 is about this solubility table. And we actually talked about it, especially in Zoom, that we have different compound showing their solubility in this table. And then on the left side is how much of this compound can be dissolved per 100 gram of water. Okay? So with the set amount of solvent, you can actually compare which one has higher solubility. And at the x-axis is the temperature. As you can see, most of the compound can be dissolved more or increase their solubility when the temperature increases, but the gases. Okay? Gas actually decrease their solubility when the temperature increase. All right, let's do our problem. First, what mass of each solid would dissolve in 100 ml of water at the following temperature, KNO3 at 70 degrees Celsius. So 100 ml of water is the standard unit of our y-axis. 100 ml, 100 gram. Gram, ml, they can interchange, okay? Because 1 gram is 1 ml. But that only applies to water. And then our compound is KNO3 potassium nitrate at 70 degrees Celsius. Let's find our KNO3 first. KNO3 is right here. Okay? And then at 70 degree, let's find 70 degree. 70 is right here. So we go all the way up to KNO3. Okay, the intersection, and look at its solubility is 130. So the answer is 130 gram. Okay. The second question, what mass of each okay. The second question is the same question but different compound. Ammonia chloride. Ammonia chloride at 50 degrees Celsius. Let's find ammonia chloride at 50 degree. So 50 degree is right here, the circle. Ammonium chloride is right here. So go from 50, go all the way up. When it hit ammonium chloride, the intersection of the x and y axis, it's 50 gram per 100 gram of water. Next, same thing, but different compound, which is okay, one second. Is potassium chlorate at 100 degrees Celsius. So let's find it. 100 degrees Celsius right here. Right here. Potassium chlorate is right here. It's this line, curved line. So 100 degree, go all the way up, 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 up. The intersection of the line of potassium chlorate and the intersection of the y is 60. So the answer is 60. Okay. Number 4, which compound is most soluble? Most soluble means it can be dissolved the most amount in the same amount of water, right? So it's the most soluble one at 50 degrees Celsius. Let's see. 50 degrees Celsius is, okay, let me erase that. So 50 degrees Celsius is right here. Okay, Which one is the most soluble? The most soluble is the one is on the top, the highest. So you draw a line all the way up. Okay, all the way up. All the way up. All right. So which compound is at highest? Sodium nitrate, NaNO3. So NaNO3 is the one's most soluble at 50 degrees Celsius on this table. Okay. Which substance is least soluble? Least soluble at 10 degrees. So least soluble means it's at the lowest of the table. Right? So at 10 degree, the least soluble, I don't even have to go all the way up. The lowest is this one, which is KClO3. Okay? Next, how much sodium chloride can be dissolved in 200 grams of water at 50 degrees? So remember, in our table, everything is compared to 100 grams of water, right? So 200 means you have to have double the amount of the NH4Cl at the solubility. So let's just find how much NH4Cl, ammonium chloride, can be dissolved in 50 degrees Celsius in that table. Okay, so let's find out 50, and let's find our ammonium chloride. So 50 all the way up to ammonium chloride is actually 50. So 50 gram ammonium chloride per 100 gram of water, right? So 200 gram of water is double the amount of 100. So the solubility or soluble amount should be doubled as well. Your answer is 100 gram of ammonium chloride to be dissolved in 200 gram of water. Right? Number 7. Label the following solution as saturated, unsaturated, or super saturated. A solution that contains 70 grams of sodium nitrate at 30 degrees Celsius. Okay, let's find sodium nitrate at 30 degrees Celsius. So sodium nitrate, hold on a second. Let me erase that. Sodium nitrate is right here. 30 degrees Celsius is right here. So the intersection of the 30 to sodium nitrate is this dot. This dot is approximately 95 grams of sodium nitrate dissolving 100 grams of water. But the actual amount we have is 70 grams. So 70 is lower than maximum amount of soluble amount of sodium nitrate to be dissolved, right? It has not reached its maximum. So if the number or amount of compound is below its solubility or max capacity of solubility, it's unsaturated. So this question is unsaturated. Okay, and saturated. Okay, the next one, the same question, but you have 20 grams of ammonia at 80 degrees Celsius. Let's find 80 degrees Celsius ammonia. 80 is right here. Ammonia, where's ammonia? Okay, ammonia is right here, which is this curved line, right? This curved line. So the intersection is right here, which is about 15 grams. So at 80 degrees Celsius, ammonia's solubility is 15 gram. But what we have is 20 gram, right? So it's above its saturation value. When it's above its saturation value on the table, this solution is super saturated. Super saturated. Oh, I wrote in the wrong place. Sorry. It's number 8. Super saturated. Super. Okay. Number 9. Label the following solution as saturated, unsaturated, or supersaturated. So we have 50 gram of ammonium chloride at 50 degrees Celsius. 50 gram so ammonium chloride at 50 degrees Celsius, 50 ammonium chloride. Okay, so this point is interaction, and then its solubility or saturation level is 50 gram. And then we happen to have 50 gram, right? So it's right at its maximum amount of solubility level. So this solution should be saturated. It is saturated. Okay, saturated. Okay, so next few questions about percent solution. So you have to remember, in order to find the solution percentage, okay, not the molarity or molality, they all represent certain concentration. However, solution percent is more vague and not very accurate. Molarity and molality are more accurate, but used in different places. So all you have to do is memorize or know your formula. Percent. Let me raise it up. So percent of solution is equal to mass of solute over mass of solution, or is equal to volume of solute over volume of solution. Okay? Either one of these, either you use the mass or volume, depending on what information is given to you in the question. So here, how many gram of sodium chloride? So sodium chloride here is a solute. Okay? Mass of solute. To prepare 50 gram, which is the mass of solution of 45%, right? Plug those number and give information into your formula. Percent equal mass of solute over mass of solution. Percent, 45%. Equal mass of solute, which we don't know, let's use X, over mass of solution, 50 gram. Okay, and you can cross multiply. You can assume 45% is 45% over 1. You cross multiply, right? X equal 45% times 50 gram. However, when you punch a calculator, you can either put in 45% or you do 0.45. Convert percentage to decimals, divide by 100, convert decimal to percentage, multiply by 100. Okay, and then 45.45 times 50. 0.45 times 50 is 22.5. So it's 22.5 gram. Okay, that's number 10. Number 11, the mass percent is the number of mole of solute which are dissolved per liter, which is wrong. Mass percent is mass of solute over mass of solution. The definition here is a definition of molarity, so false. Next, what is the percent by volume of a solution prepared by adding water of 30 ml of isopropyl alcohol until the volume of solution is 600 ml? So, straightforward. We're looking for percentage, okay? And we're looking for percentage. We have the mass of solute, and then we have the mass of solution. Percentage equal mass of solute 30 ml over, not mass. This time we're using the volume. So volume of solute is 30 ml volume. And then volume of solution is 600 ml times 100%. Right? So it's 0.05. Okay, that is correct. So it's 0.05 convert to percentage times 100% is 5%. Right? So the answer is 5%. Number 13. What refers to the amount of solute dissolved in a given amount per volume of solution? Well, concentration. That is literally the definition of concentration. And this is what we've been dealing with the whole time, right? For molarity, mass percent, they're all concentration. How many grams of water are needed to add to 4 gram NaOH to create a 2% solution? So, if we assume the solvent here we're looking for, water is not a solution, water is a solvent. Okay? Remember our percentage. Percentage is mass of solute over mass of solution. So what is solution? Solution is the entire thing. What's the entire thing? It's the mass of what you're dissolving plus the mass of what you're doing the dissolving with, right? So solution is equal to solute plus solvent. Okay? So from this equation, we can find our mass of solution first. We plug in the information, 2% equal, our solvent is 4 gram over X. Cross multiply. Okay, so X equal 4 divided by 2% is 4 divided by 0.02, which is 200. So 200 gram is our solution. In order to find our solvent, which is water, okay, we need to use solvent equal solution subtract the amount of solute equal 200 grams subtract 4 gram, which is 196 gram. And this is the amount of water we're looking for. All right. So this quiz is going to be on Friday at 1 p.m. and you will be given with different number to find your answer. And all the answer are going to be multiple choice. So set your alarm and good luck.